All right, welcome back for week 3. We're going to start talking about chapter 8, lesson 2. So, we're going to start with a warm-up for this week because I think it's a little more difficult than the other warm-ups have been, and I want to go over some of the vocab for this. Okay? Uh, we're going to get onto the main topic later, but we're going to talk about perimeter and equilateral first. So, perimeter, that means the measure of all sides of a shape. So, if you have any shape really, and you measure all the sides. So here's my rectangle. This side's going to be 6, and this side I say it's 3. Now what could I say is the perimeter of this? Well, I'm going to add them up. 6 plus 3 plus the other two sides. Now that top side, it's the same as the 6. And that left side is the same as the 3. Add that all up, and we get 18 for the perimeter. Okay, because I measured all the sides and added them up. Okay, they can also work like this. So, like we're in Algebra 1, not all sides are going to have numbers. One side might be x. So I still can add them up. X plus 2, the top side's x again, and the left side's 2 again. Add these up. It's not too bad. We get x plus x, which is 2 x's. We get 2 plus 2, which is 4. And there we are. That is the perimeter. Even though it's not one plain number, it is still a number. It is a polynomial, like we talked about last time. So things get more complicated in algebra, but we can still add all the sides up to get perimeter. All right, let's talk about equilateral now. So equilateral means all sides have equal length. So if I draw, it's usually used for triangles. So if I draw a triangle here that is perfectly the same size, look at that, beautiful. So this triangle is equilateral, and I can mark that by writing these tick marks. One here, and one here. So those, you see those in geometry a lot, and that means all the sides that have the same mark have the same size. So that's how we know this is equilateral, even though my drawing's not perfect. It's beautiful though. Okay, so this is what it looks like on our warm-up. The first question on the warm-up has a triangle just like this. And they tell us that the side on the bottom is 3x squared plus 5x plus 12 long. So that's how long that side is. It's a complicated polynomial number, but it still is okay for what we need to do. So if this side is 3x squared plus 5x plus 12, this side must be, well, it's equilateral, so it must be the same. 3x squared, blah, blah, blah. Same length. And that also means this side has to be 3x squared plus blah, 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 blah. All three sides are the same. So if we want to add up all three sides, because we want to find the perimeter, that's what the question asks us in the warm-up. We want to find the perimeter, we need to measure all the sides. And if we add them all up, like we did with the rectangles before. So one side is 3x squared plus 5x plus 12. I'm going to run out of space here. Plus 3x squared. This is the second side. 3x squared plus 5x plus 12 plus 3x squared plus 5x plus 12. So that's all three sides added together. And that will give you the perimeter. Okay? It's the same as saying that we have 3 of this side, because they're all the same size. So you could also write, if you want to distribute instead, 3 times 3x squared plus 5x plus 12. Whoa, that was an interesting sound. Okay, anyway, so we're distributing. That was a big notification, huh? All right, so we could distribute this 3. You do 3 times the first, the second, and the third number, and you would get the same answer. I'm not going to do it here. You can try it in your warm-up now that I've helped you set it up. But let's move on to today's topic. Today we're talking about multiplying a polynomial with a monomial. So remember, last week and these things over here, those are polynomials, right? We talked a lot about polynomials where they've got, 2x plus 5 plus 7x squared. Those are polynomials. Here, we're going to start multiplying them instead of adding like we did last week. Okay. So, let me get the camera adjusted perfectly. Alright, so we're going to multiply a polynomial by a monomial. And I'm going to use examples that are not from the packet, okay? Because the packet does not have very many problems this week. So I want you to practice in the packet, and I'll give you different examples here. Now, if you get stuck, that's okay. Come talk to me. Send me a chat. Oh, I'm untangling here. Send me a chat. Come to my office hours, right? We have class time at 11:15 on Tuesdays and Thursdays. We have open time for questions every Monday, Tuesday, Wednesday, Thursday at 1 p.m. And at 6 p.m. those same days, you can talk to me. Okay? And on Friday, 9 o'clock to noon, I'm also available. Okay, back to the problem. So we're going to multiply a polynomial by a monomial. So let's start with our monomial. That's going to be 5w. Now this is a monomial, we know, because it has only multiplication in it. Okay? We see that there's not 5 plus w, it's 5 times w. That's okay. Now in the parentheses is going to be our polynomial. Okay, we've got negative 3w squared plus 2w minus 4. Okay, so that's our polynomial in the parentheses here. It has 3 pieces. They're separated by the pluses and minuses. And then our monomial, we put it in front to multiply. It's over here, the 5w. Okay, so we're going to distribute. We've done this before. Sometimes you call it FOIL when it's double distribution. But we're going to multiply the 5w by each piece. Okay? So let's color code it. Starting with purple, we're going to multiply the 5w times the first term here. Then we're going to multiply the 5w times the second term here. And we're going to multiply the 5w times the third term here. Okay, so let's start with our purple. Oh, don't want to forget that when it's a negative term like this, you have to include the negative. So the negative 3w squared is part of what we're multiplying. Just like this negative 4, the negative is included too. So be careful with that. Okay, let's get back to 5w. 5w, we're including the negative with the 3w squared. So let's get ready to multiply them. Okay, so let's multiply. 5w times negative 3w squared. 5 times negative 3, that's negative 15. Then w times w squared. We're multiplying bases, so we're going to add the exponents. This first w has an invisible 1, so it's 1 plus 2, which is w to the third power. Okay, purple line is done. Alright, now we're going to multiply the blue line. Multiply the coefficients first. 5 times 2 is 10. Then w times w. The first w, we know it has an invisible 1. The second w, it also has an invisible 1. Okay. W times w, 1 plus 1, w squared. Okay, it was a positive 10 and positive w squared. When we multiplied, they were both positive, so it is going to be positive between them. So plus between them. Okay, on to our green line. On the green line, we're going to do 5w times negative 4. So we're going to start with 5 times negative 4. That's going to be negative 20. And w times empty. If there's nothing there, it's a 1. We know that. Not a 0. So 5w times 1, it's going to stay as w. Okay, so negative 20w. You could put the 1 up there if you needed to, but okay. Now let's see. Do we have anything we need to combine? No, because this is w cubed, this is w squared, and this is w. They can't add together, so this is our final answer. And it's neatly in order. 3, 2, 1. The exponents should go down from highest to lowest. Okay, let's try another example. Example 2. Remember, these are not in the book. These are just examples that I want to go through. If you need help with the bookwork, let me know. Okay, 2ab, that is a monomial. 2 times a times b. Not 2 plus a plus b, so it's good. This is a monomial. Okay, 2ab times, the parentheses means times, 7 a to the fourth, b to the second, plus a to the fifth, b minus 2a. Okay, so that inside the parentheses, that is a polynomial because we have pluses and minuses between different terms. This polynomial, it's a trinomial. It has 3 terms. So we're going to multiply the monomial with each term. First, the purple line, then this blue line. That was term 1 for purple, term 2 for blue, and term 3 for orange. Oops, orange line. So remember, the orange line needs to include that negative. Don't lose that. Okay, let's try our multiplication. It looks scary. This one has lots of a's and b's, but we'll go step by step. So purple line, 2 times 7. Right, we always start with our coefficients if we can find them. 2 times 7 is 14. Next, a, well that a, remember, that a has an invisible 1 exponent. And that b, let's do it for now, that b has an invisible 1 exponent. So a1 times a to the fourth, 1 plus 4 is 5. So it's a to the fifth. B, Remember, this b has an invisible 1, and that b has a 2 exponent. 1 plus 2 is 3, so it's b to the third. Okay. Next, let's go with our light blue line. 2ab times a to the fifth b. So 2 times empty. If it's empty, it's not 0. It means there's an invisible 1. So I'm going to write my invisible 1. All right. Perfect. So 2 times 1 is 2. Next, a to the first times a to the fifth. Add the exponents to get a to the sixth. Alrighty. B to the first times b. Now this b, it's got an empty exponent, which means it's an invisible 1. So b1 plus 1, which is b squared. Okay. Now this whole term was positive, so we're going to put a plus between it, in front of it. All right, let's go around for the orange line. Starting with 2 times negative 2. There's our 2 and our negative 2. It's going to be negative 4. Then we have a to the first times a to the first. Remember, invisible 1. So 1 plus 1 is squared. So when we multiply the bases, we add the exponents. Now we've got b to the first times an empty space. If it's empty, it doesn't mean 0, it means 1. So b times 1 is just b. And you could put the invisible 1 up there. That's okay too. But you can make it invisible again if you like. So this is the correct answer, and that's a b, not a 6. Alrighty. We just check. There's nothing to combine here because all the variables have different exponents in different orders. So, a to the fifth and b to the third cannot add with a to the sixth and b to the second. So things have to stay how we wrote it. All done. Okay, moving on to the last board for today. This is going to get a little more advanced. Now we're going to simplify, which is what we've been asked to do in a lot of these problems. That means, basically that's just going to mean that we have to do more than one step for each problem. So this is my example number 3, not from the book, remember. X parentheses 4x squared plus 15x plus 4. So that's just like we did on the last board, nothing crazy. It's similar to what we did. Now we have minus 4 times the parentheses 3x minus 1. So this problem, if you want to look at it, it's really just 2 of the old problems together. So we will start with the x distributing to its parentheses. So x distributes to this term, and to this term. So the x only goes to its own parentheses. It doesn't go over to the other side. Okay. Now on this side, this negative 4 here, it needs to distribute to its parentheses. It will go to the first term and the second term. Okay. So let's start it out. Starting with the first terms. Well, let's use our purple instead of our black. All right. So first off, remember, if the x has an empty exponent, it's exponent 1. And if the x has no coefficient, it's that invisible 1 coefficient. So let's add these 1's in there. Then let's try it out. 1 times 4 is 4. X to the first times x squared is x to the third. 1 plus 2. All right. That one's set up. Let's try our blue line. So 1 times 15, that's 15. X to the first times x to the first, right? It's empty, so it's a 1. 1 plus 1 is x to the second. Okay? We got to check if is the whole thing positive. Yes, so we're going to put this plus in here. All right, pink line. 1 times 4. Okay, that's 4. X times empty. Remember, if it's empty, it's a 1, so it stays the same. X plus 4x. It was positive, so we put a plus. Okay, so that piece of the problem is done. Now let's try the second parentheses problem. We got a negative 4 times 3x. Okay, so let's do the numbers. Negative 4 times 3 is negative 12. Nice. X times empty. There's nothing with that 4, so it's a 1, which means we just leave it like it is. So it's negative 12x. Okay, get rid of that one. Oh, bad catch. All right, try the blue line. Negative 4 times negative 1. Negative times a negative is positive 4. All right, so this is the answer, but it's not the cleanest answer, right? We want to simplify, so we don't want two different terms that have x in them. We have only one term with x cubed, one term with x squared, right here, one term with x cubed, one, there's no other x cubed, so we can't add it to anything. So it's done. Put it down in our final answer. 15x squared. Is there another x squared? No. So let's put it down in our final answer. Okay, 4x. Is there another plane x thing? Yeah, right there, that negative 12x. So 4x minus 12x is negative 8. So those two can combine with each other. They are like terms, so they can combine to negative 8x. Okay? And then plus 4. Is there another plane number anywhere? Nope. So it's just plus 4 at the end. And this is our final answer. And it is all neatly set up so that we have x to the third, then x to the second, then x, then 4. So everything is in the right order. You start at the highest exponent and go down. So that's a very nice answer. Okay, so we're going to do one more difficult type of question. So remember, these are examples. It's this week. I did not do it from the book, from the packet. So if you need help with the packet work, just come to office hours or to class time. So now we want to solve equations with our new skills. So now that we know how to multiply polynomials and combine like terms and all this good stuff, we want to use it to solve equations like we did before in algebra. So here's my example number 4. And what we're doing in this equation, or this example, oops, dropped my pen, is we're going to solve equations with our new skills. So we've got x times 2x plus 3, okay, not too bad, plus 20. So the plus 20 is outside the parentheses. Then we've got equal sign, so we've got an equation going. On the other side of the equal, we have 2x times x minus 3. Close the parentheses. Okay, so we're going to start. We have one thing that looks like an old problem we did, and we have another piece that looks like an old multiplication problem from the last board. So, or from this board. So let's do them piece by piece. The x needs to distribute to each thing in its parentheses. So each term is going to multiply by x. So let's do the purple first. X times 2x. Well, 2 times 1 is 2. X times x, they each have that invisible 1, so it's going to be an x squared. Okay, very nice. Then the blue line, we have x times 3. If you have 3 x's, that's going to be 3x. 3 times x is x. Ah, sorry, 3 times x is 3x. Excuse me. Okay, That was the whole thing that was in the parentheses. So let's move to the next piece. That 20 was not in the parentheses, so it did not change. Whoa, my hand lost control there for a second. Let's clean that up. So this 20, it was outside the parentheses. It just comes down by itself. Nothing changed with the 20. Same with the equal sign. Equal sign just moves down. Okay, so we're done on this side. Let's try out the other side. It's just another multiplication problem. So we do 2x times the first term and 2x times the second term. Don't forget to include the negative. All right, so orange line, 2x times x. Well, it's going to be 2x times x. Remember from the other part, we have a invisible and invisible 1. So we have 2x squared. Okay, not bad. Now we try our green line. I think I dropped my marker. There it is. Okay, 2x times negative 3. All right, let's multiply the numbers first. 2 times negative 3 is negative 6. X times empty, it stays as x. Okay, so this is nice. We got it a little simpler, but we need to keep going. For an equation to be fully simplified, you can't have x's on both sides of the equation. We want to get rid of some of these. And we got to use our old algebra skills. Remember, don't call me after midnight? So the first thing we want to try, we're going to get rid of the biggest exponent we can. So remember, we can draw our line down our equation, equal sign. A lot of you guys use this strategy. That's a good strategy. So remember, whatever we do on the left, we need to do on the right. And something I can notice here, it's going to help me. I have a 2x squared on the left, and I have the same thing on the right, 2x squared. So my purple and my orange are the same. That's going to be very handy. So I'm going to subtract 2x squared from both sides. And we'll notice, so 2x squared minus 2x squared and minus 2x squared, one on each side. And when we do that, you'll notice that 2x squared minus 2x squared, they're gone, delete. 2x squared minus 2x squared, they're gone, delete. That makes it so much simpler. So if you notice the same thing on both sides, try subtracting them, okay? You could clean up your equation a lot. Okay, 3x plus 20, neither of those changed. And on this side, we still have negative 6x. Okay? Next part of don't call me after midnight. So we're at moving the smaller variable. Okay? Sorry, I got a cough. All right, so we want to move the smaller variable. Negative 6x is smaller than 3x. Negative numbers are smaller than positive. So because this is negative 6x, we're going to add 6x to both sides. Okay. So on the left side, we got 3 plus 6 is 9x's. The 20, oh, you know what, I better do this in black ink because it's an answer, a part of the answer. 9x. The 20, nothing changed, so it's plus 20 still. Equal sign still in the middle. But on the right side, we got a 0, right? If you have negative 6 plus 6, you're back to 0. Okay, next part of it is add or subtract the constant number. So we're going to subtract the 20 from both sides. So delete that 20. And on the right side, 0 minus 20 is negative 20. Okay, then we need to divide by the coefficient. So divide by 9 on both sides. We get x on the left side, and we get this fraction on the right, negative 20 divided by 9. You can keep it as the fraction, that's okay. Or you can check your calculator and see that it is negative 2.222222. So there we go. We have our answer. So remember, if we want to solve an equation with all these tools we have now, the end result we want is x equals something. We did all these steps, so it looks like a ton of work, but each step was not too hard. right? These are all little things that we know how to do. We're doing them all together in one problem now. Okay, so remember, if you need any help on this or anything else we did today, you can come meet with us on Teams Tuesdays and Thursdays at 11:15 a.m., Monday, Tuesday, Wednesday, Thursday at 1 p.m., Monday, Tuesday, Wednesday, Thursday at 6 p.m., and Friday from 9 to noon. All right, see ya.